we will be granting abilities to ability slots. But what exactly are these ability slots? Well, in most games, abilities are bound to certain slots, and optionally, these slots are also bound to certain input keys. For example, in Dota, you have 3 abilities and 1 ultimate, and these abilities are bound to the input keys Q, W, E, and R. Optionally, you could also have a 4th and 5th ability that would be bound to your D and F keys, for example, maybe Invoker. Beyond abilities, you could also have slots for items, like how in Dota, you have 6 item slots, where each item could itself be an ability. And beyond items, you could also have emotes as abilities, and they could be bound to a certain emote slot, which itself could be bound to a certain input key. You could grant additional abilities into ability slots, so you can dynamically increase the number of abilities for a particular hero and also change their slots like how you do with Dota's inventory. So we're not going to be using input IDs in ASC, rather we'll be using ability slots for many different abilities, including passive abilities. So to implement such ability slots, I wish to map gameplay tags to ability classes. And in this section, we will be learning how to grant abilities in C++. Now in your preferred editor, open up the base character header file. In the very bottom of this class, go ahead and create a new section called Abilities. And here we will create the map for the ability slots, and using Unreal Engine's tmap, which is actually what is used to create maps in Unreal Engine C++. This map requires 2 template parameters, that is the data type of the key value pairs. We know that our key is a gameplay tag. I will add the first template parameter fGameplay tag, and under this, I will add the data type of the value, which is a class of the gameplay ability, as T subclass of uGameplay ability, and this is how you declare a map in Unreal Engine C++. I wish to make this initial ability container property to be edit defaults only. Go ahead and declare a method giveInitialAbilities, and also I will add another property which will be like a boolean flag variable. This will be set to true when all initial abilities are given to this character. Open up your Blueprint Hero. In the class defaults of Blueprint Hero, notice how you have an ability system category within which you have the ability subcategory, and now you have the initial ability container. You can now start adding the key value pairs of an ability slot gameplay tag and an ability class. So the trick is to activate an ability by querying for its slot. So now we need to give ability in C++. Now in the GAS documentation's granting abilities section, it states that granting a gameplay ability adds it to a particular list in that ASC, known as activatable abilities. So just like effects, gameplay abilities are granted on the server. We will be using the gameplay ability specification structure in order to grant abilities. Using a for each loop, they are granting the startup ability from that array of gameplay ability classes. So granting of an ability is done using this ability system components giveAbility method. It needs a gameplay ability spec, and that itself is a structure constructed using several parameters. So let's go ahead and implement this method, iterating through the elements of our map. So now in your C++ giveInitialAbilities definition, let's first validate if our abilities were even given. So if already given initial abilities, let's simply return. So if this local role is not equal to role authority, and role authority being a constant to represent the server, then we are not the server and we shall simply return, because abilities can only be given on the server. It is time to iterate through our initial ability container, and within this for loops expression, we are going to iterate by element and not by an integer index. So this is a C++ syntax. Declare a variable called ability pair and use a colon to indicate that it is a single element of this map initial ability container. But we need to specify the data type for this ability pair. The data type is actually a T pair of a gameplay tag to an ability class, but I just wish to use auto, and this will auto cast this ability pair's data type to a single element of our map. I wish to pass by reference so that this ability pair is not instantiated in every iteration. Rather, it simply references each element in this initial ability container. Within this for loop, let's first create the gameplay ability spec. And this implements a constructor to initialize this ability spec, and that has this method signature. It requires a parameter, ability class, the ability level, and an optional input ID. Note that the class is a value in this ability pair. We will use the property value, which is actually the class gameplay ability. So now we have been able to construct an ability spec for this gameplay ability class. It is now time to grant this ability spec. So in a new line, use the ability system components method giveAbility, which takes in only a single parameter, and that is the ability spec. So notice how it is actually passed by reference. So this is the reason why we had to initialize this ability spec outside the giveAbility method, whereas in the GAS documentation, it has directly been constructed inside the giveAbilities parameter. So make sure to construct an ability spec outside in order to pass by reference. If we complete this for loop, it means all of our abilities are given. I will just mark this given initial abilities variable to true. Within this for loop, let's validate this ability pair's gameplay ability class value. And also, to be on the safer side, I wish to also validate that raw class pointer. That is done by calling the class's get method, which will simply return the generic Unreal Engine class pointer. And also, it's a good practice to validate this ASC itself. We should invoke this giveInitialAbilities method in the right place and at the right time. So we will be doing that soon after initializing the ASC's actor info. So in both these methods, replicated player state and possessed by, go ahead and call this giveInitialAbilities method. So now in your editor, open up the Blueprint Hero class and make sure in your ability system category's initial ability container property, you have the appropriate data. So now we are expecting this melee ability granted to us. But for testing purpose, let's use our gameplay ability test. In order to invoke that ability, we will attempt to query for that ability class in that ability slot. So go ahead and cast this control pawn to Blueprint Hero and access its initial ability container. And let's look for combat.melee. If it has been found, we are expecting that melee ability class, and we are expecting the gameplay ability test. And call tryActivateAbility by class. So this is what we'll be doing in this tutorial series to activate any ability. It is all done by querying for that ability slot. So this is a great way to also activate abilities in your AI characters, where if you have an AI minion or a tower or something like that, and now in my client 1, if I press left mouse button, notice how our test ability is activated. Yeah, great. Now let's replace test with melee, and the left mouse button activates a melee ability. Great. So in that manner, we have been able to grant, implement, and activate our melee ability. Now let's quickly learn how to apply startup effects in C++. So just above this ability section, create an effect section. Always in GAS, go in this order: attributes, effects, and abilities, just like the GAS solar system. Make a property that is an array of gameplay effect classes, and that will be known as initial effect container. So we'll also have a boolean flag variable and an apply initial effects method. So in this apply initial effects method, if we have already applied initial effects, then return. If our ASC is not valid, then again return. And the third validation check, if the local role of this character is not the server authority, then return. Now in the similar for loop, where we're iterating by the elements of the initial effect container and accessing by reference. So for each effect class in initial effect container, if we don't have a valid effect class, then return. Gameplay effect specs are applied just like in blueprints. It is done using the apply gameplay effect spec to self method. where we need to pass a gameplay effect spec by reference. Just like in blueprints, we need to call the ability system's make outgoing spec method, which will give us an outgoing effect spec, but not as you expect. It won't return an F gameplay effect spec, rather something known as an effect spec handle. So technically, you will have to declare an effect spec handle that references the return value of this ability system's make outgoing spec method. So this requires 3 parameters, as in blueprints: the effect class, the effect level, and the effect context handle, which can simply be made using the ability system's make effect context method. So yeah, this method is just like its blueprint counterpart, where if you remember in the burn area actor, this also simply returned the effect spec handle. This is a really weird part, where in blueprints, it accepts an effect spec handle, but whereas in C++, it requires the gameplay effect spec. This is actually contained within this effect spec handle, so it's time to extract the effect spec from this effect spec handle. This data property is actually something known as a shared pointer of a gameplay effect spec. So if we use that, it is still not the valid parameter, a constant gameplay effect spec. So from this data, use a dot operator, and we shall use this get method. This get method returns the object pointer of this gameplay effect spec. We still get these red squiggles. We are trying to use this object pointer for a parameter that requires the object itself. So what we're going to do now is dereference this pointer, and that is done by simply using an asterisk in the very beginning of that object pointer. And so in this manner, we've got the effect spec from this effect spec handle. Yeah, I know it seems very complicated, but it's not really. And now it's time to call this apply initial effects method along with the give initial abilities method. For that purpose, I've created a new method known as initialize ability system. Make sure to call the effects first before the abilities. Always remember the gas solar system. Effects come before abilities. So now, I have replaced the give initial abilities method with initialize ability system method itself in the possess by method after initializing the ability system's actor info, and likewise in the onReplicated player state method. You can also call this initialize ability system method in this character's begin play, and now save all of your classes and build and compile your code. Open up your Blueprint hero class and search for your ability system category, within which notice how you will now have an effect subcategory containing the initial effect container property. Go ahead and add as many effects as you'd like. First instant, and then infinite. For testing purpose, let's deliberately leave this class as none, and notice how the initial effects have already been applied. You can see the heal.fountain tag that was part of the heal infinite, and the healing started off after the value 200. Instead of button spamming the left mouse button, let's implement this such that we can simply hold the melee button and it keeps periodically doing melee. That will be a small task for you, so try using timer events. Pause this video here and come back when you're done with the implementation. Okay, I hope you have completed your implementation. So in this left mouse button's press event, I will set a boolean variable melee held to true. This melee held variable is a property of this player controller, so this will be turned off or false when the left mouse button is released. Now when the melee is held, we shall periodically invoke melee. So I'm using this method setTimerByEvent, and I've created a new custom event for this timer, and I'm looping this timer every 0.02 seconds, and I'm storing the timer handle into a new melee held timer variable. So in this event triggered melee, if my melee is held, then I will activate the melee ability at the combat.melee slot. So technically this function executes independently due to this melee held timer having been activated. But now we have to clear and invalidate this timer whenever we release. I've done that in the same triggered melee event, where if our melee held value is false, I will simply clear this timer by calling its clear and invalidate timer by handle method. So once this method is invoked, this whole event's functionality will be stopped. The melee is being played without me repeatedly clicking the left mouse button. And if I inspect the debug information of another client, notice how the melee damage is being applied. Now let me quickly go through these gameplay ability properties. you have a property ability tags. So for my gameplay ability melee, I've used the combat.melee gameplay tag. The cancel abilities with tag container is meant to cancel other abilities that bear any one of these tags. The block abilities with tag is used to block other abilities while this melee is active. Like maybe if you wanted to block jump, you could just say combat.jump, and until this ability is cancelled or ended, it shall block you from activating an ability containing the combat.jump tag in its ability tags. So activation owned tags is meant to grant these tags when this ability is active, and we're granting the combat.melee tag. Activation required tags is meant to validate the activation of this gameplay ability only if the ASC has all of these tags. Activation block tags is made to block the activation of this ability. So I've used the combat.block gameplay tag, and this blocks the activation of gameplay ability melee. You have source required tags, source block tags, target required tags, and target block tags. This is used to validate the activation or block the activation for the source or target actors. Now in the advanced category, we have a property replication policy. Just leave this to do not replicate, because replicate will create an instance of this ability in every machine in that session. Instancing policy is to specify how you want to instantiate this ability. There are 3 instancing policies: instance per actor, instance per execution, and non-instanced. Instance per actor will instantiate this gameplay ability for every ASC that it has been granted to. So this is what you will use the most. And since this is an instanced object, it can have variables and change state. Instance per execution will instance the gameplay ability every time the gameplay ability is activated. So if you activate melee 10 times for the same actor, then melee has been instanced 10 more times. So this is something that you don't want to use. The sample project does not use any of these abilities, and these have the worst performance than the other instancing policies. And finally, the non-instanced instancing policy, where this gameplay ability is operated on its CDO, or the class default object. So CDO in Unreal Engine is just like one small instantiation of a class, and just like a simple static class, a CDO cannot have states, and quite behaves like a static class itself, and this has the best performance of the other instancing policies, but it is the most restrictive. Because since this behaves like a static class, you cannot have changing variables, and also you cannot use any ability task in a non-instanced ability. So you can use this for a very simple ability, like maybe jump, or some minion basic attacks. So another great place where you want to use the non-instanced abilities is where 100 or more actors need to be granted the same ability. Meaning instead of instantiating an ability more than 100 times for each actor, for maybe a battle simulator, then you can simply use non-instanced and you won't instantiate any ability. You may want to leave every other property untouched. That is, server respects remote ability cancellation, meaning the server can cancel the client's ability and vice versa. This is a very interesting property. If you try to activate an already active instanced ability, it will automatically end that ability and re-trigger it. Now gameplay costs are nothing but gameplay effects. So if you use a gameplay effect, such as a stamina cost for melee, then this cost will be applied as a gameplay effect, obviously in the server. That can be done using this method, commit ability cost. So let's just quickly create an effect cost in our base folders, ability system, and effects folder. We'll call this gameplay effect melee cost. So this will be an instant gameplay effect, meaning I instantly want to modify its attribute, and that will be stamina. But now, even if I attempt to activate melee again, melee is not being activated. That is because our stamina has been committed and we don't have the resources to perform the melee ability again. But how does GAS know to stop at stamina 0? GAS assumes that your stamina cost should be clamped within 0. Ability triggers is used to trigger an ability using an event, which we will perform in a future topic, and gameplay effect cooldowns are also effect classes, just like costs, using the commit ability cooldown method. If you want to do both of these simultaneously, you have one single method known as commit ability. You can also check ability costs by calling the check ability cost method, which only checks to see if any of these modifying attributes won't go below 0. And that's like the funny part of Gas. It should have allowed us to add our own minimum value. Similarly, you can check for the ability cooldown. Let's quickly explore this cooldown effect. Unlike the melee cost, this cooldown effect is not instant, but it's a duration effect. And this duration magnitude is nothing but that cooldown magnitude. So let us choose maybe 6 seconds. We don't really need to make this periodic, but how a cooldown is determined is using a gameplay tag. And that's another silly thing about Gas. It needs tags even for cooldowns. Let me show you what I mean. So for this gameplay effect cooldown, let's commit that, and we expect a cooldown of 6 seconds. So let's just simply grant a tag, maybe element, and notice how I have the element tag, and I'm not able to perform melee until that element tag has been removed. So yes, we'll be exploring more of costs and cooldowns in chapter 3, but note that if you have a single cooldown tag, this can block the activation of another ability if it also uses the same cooldown tag. That is, you should use a combat.melee.cooldown, a combat.jump.cooldown, maybe a combat.block.cooldown, a combat.dodge.cooldown, and so on. So it is recommended that every ability has its relevant cost and cooldown tag, because it is the existence of this tag that blocks this melee's activation, similar to activation block tags. So this brings me to the end of this topic, and we have successfully implemented melee as a gameplay ability, along with its costs and cooldown. Although, we will explore more about costs and cooldowns in chapter 3, for abilities such as double jump, sprint, and dodge. Let me summarize the steps in this topic, but in reverse. So in the last section, we learned how to apply initial effects. This was done in the base character C++ file in the apply initial effects method, where for a particular initial effect container, which is nothing but an array of effect classes, we applied the gameplay effect spec to self. In this method, we iterated through each element of an initial effects container. This effect spec was obtained from the effect spec handle using makeOutgoingSpec method, and dereferencing the pointer to the effect spec contained within this effect spec handle data. And since this returns a pointer, we had to dereference that pointer for the gameplay effect spec parameter. This also requires a prediction key, which we have declared in the very beginning of this function, but we will learn more about prediction in the future. And also, make sure to do the appropriate validation checks, that is, if your effect class is valid, if you're actually calling this method in authority, so you can now add as many gameplay effects as you'd like. In section 5, we granted abilities in C++ into ability slots. So ability slots are technically placeholders for various abilities of an actor. So even if you dynamically grant an ability, you can have it in a particular slot. You can also swap abilities into different slots, like changing item positions in the inventory. So this allows dynamically granting abilities to different actors, for example, like in ability draft in Dota, where different heroes can have abilities of other different heroes. So for that purpose, we created a map called initial ability container, which can be set in the blueprints in the class defaults of this character, mapping a gameplay tag, which is the ability slot, to a gameplay ability class. So this was implemented in the giveInitialAbilities method, where we used the ASC's giveAbility method. It is very straightforward, unlike applying effect specs, where we just simply apply an ability spec, which is actually a specification of an ability, which is simply constructed using an ability class, and other parameters such as the ability level and its input ID. Although we will not be implementing using this input ID, we'll rather be querying for these abilities from their ability slots, where we iterated through every ability slot pair. In the fourth section, we learned about gameplay ability properties, particularly the different tag containers, instancing policy, ability costs, and cooldowns. So instancing policy defines how you actually instantiate this ability. You do not really wish to replicate this ability, and always make sure to have your ability instance per actor. You may never really want to use instance per execution, And non-instanced is great to use when you have a simple ability that has to be given to a lot of actors, like maybe hundreds of actors in a battle simulator. I wish to make an advanced gameplay ability system tutorial in which almost all of our abilities will be non-instanced. Ability costs are nothing but gameplay effects. You can commit an ability cost using this commit ability cost method, which simply applies this gameplay effect. But note that this gameplay effect will subtract a value from a particular attribute. Gas assumes the minimum value to be 0. Even if our stamina has been clamped between -30 and the maximum in the pre-attribute change and the post-gameplay effect, Gas still stops performing this melee ability if it thinks your stamina can go below 0. So that is one weird part about Gas. And I don't think it would help if you used a meta attribute for stamina consumption, where if you overrode a value and then perform melee, notice how your stamina has been consumed and stamina meta has been set to 0, but your stamina can still go below 0 and it has been clamped to -30. Make sure to add directly to your stamina and use a particular negative value. An ability cooldown is also a gameplay effect, but this is a duration effect. We use the method commit ability cooldown, and if we need to do both of them simultaneously, we can simply use the commit ability method. We can also use these methods check ability cost and check ability cooldown, which simply returns a true value if we have the resources to consume this ability's cost, or if we are not under the ability's cooldown. And in this gameplay effect melee cooldown should not only have a configured duration magnitude, it can be non-periodic, but it should also grant a gameplay tag. So technically, Gas validates to see if this cooldown tag exists on the ASC character, and this cooldown tag is what blocks this activation of melee, similar to activation block tags. So if you use the same cooldown tag for 2 or more abilities, then both abilities are going to get blocked if even one ability is in cooldown. So make sure to have a cooldown tag for every one of your abilities, like combat.melee.cooldown, combat.jump.cooldown, combat.range.cooldown, and so on. We have packaged a map which maps its ability to the list of montages. Since we need a list inside of a map, for each row name, we had to create 2 structures. One contains an array of animation montages, and the other uses that animation montage array structure as the value of a map, mapping an ability class to that animation montage array structure. So now we get a map of a gameplay ability to a list of animation montages. So in our base folder's ability system folder, we created a new abilities folder, within which we have a gameplay ability class, gameplay ability melee. So it is in this event activate ability where this entire ability's functionality is written. We are doing the following sequence of operations. We are using the data table of animation montages, and for this hero row name, we are trying to get a montage array. We can find, for this ability class, an array of montages. So this can be used for dynamically changing animations. So we don't have to hardcode a data of animation montages, and we can use this data table for any hero that we have configured. The better way to handle such a data-driven approach would be to use a data asset. So the advantage of such data tables is that it can be designed to accommodate data for characters' weapons, if it is dual-wielded, single-handed, or two-handed. And then for the length of this montage array, we set an integer variable, montage index. This montage index is operated upon using this modulo operator. So this montage index is always clamped between 0 to 1 less than this montage array length. So this ensures that we're able to cycle through these indices and we don't exceed the montage array length. So from this montage array, we index using this integer variable, and that single animation montage is played using this play montage and wait ability task. Ability tasks are used to perform latent actions, which are used for asynchronous programming. Note that these ability tasks do not run in a non-instanced ability. So this works just like our play montage latent action that we implemented in the previous section. It is crucial to call end ability or cancel ability during this ability's activation in order to actually end this ability. If we do not call either of these methods, Gas assumes that this ability is still active and prevents reactivation of the same ability. Note that ability is not in a particular active state, Gas determines if an ability is active as the difference between the number of times it is activated to the number of times it has ended. This montage index that was used to index and get the animation montage will be incremented. And after playing the animation is when you can decide to apply the ability costs and its cooldown. And there is another event called onEnd ability, which is called whenever an ability has been ended. And this was cancelled will be true if the ability was cancelled using something like this cancel ability node. So when this ability ends, after a delay of 3 seconds, I'm resetting the montage index to 0. So this completes our melee ability. So after granting and implementing this ability, let us try to activate it. Go over to your player controller class and you can activate any ability by simply querying for its ability class at that particular ability slot. So technically, from the control pawn, try to get its initial ability container. You can query for the key combat.melee. As we had implemented, melee ability classes are bound to certain ability slots, and ability slots are certain gameplay tags. If it is found, you can use this ability system component and activate this ability using that gameplay ability class. Instead of casting like this, you could implement an interface. You can declare methods to get an ability class from a particular slot, or perhaps activate an ability at a particular slot. So what I'm doing here to repeatedly invoke melee is that during this left mouse button key event pressed, I'm turning on this boolean gate variable melee held to true. And then periodically, every 0.02 seconds, I'm using a timer to execute an event, and that event is triggered melee. So in this triggered melee event, if melee held is true, melee will be activated, and this will keep triggering every 0.02 seconds, but melee won't really invoke every 0.02 seconds, because melee only ends upon that animation's completion or blend out. And so if melee held is false, I'll just simply clear and invalidate this timer handle. So finally, in your Blueprint Hero class, in its class defaults and under the ability system category, you can now add as many initial effects that you wish to apply in the initial effect container under the effect subcategory, and you can start adding ability slot and ability classes, such as for the slot combat.melee, I'll be selecting the gameplay ability melee class. For the initial ability container in the ability subcategory, I simply have my left mouse button held and melee is being invoked repeatedly, and melee is cycling through all of the 4 animations. I hope this topic was informative. It may have been lengthy because I wanted us to take baby steps and learn things step by step, one at a time, and build a big functionality. In the next topic, we will be implementing the block ability. You can block and parry that melee hit effect, just like in Sekiro. So thank you for watching. Ask away any queries in the comments down below, and I will see you in the next one.